This problem says that Sam invested $5,000 at 10% interest. Write an explicit sequence and find f of 20. The question doesn't specify whether Sam is being paid simple interest or compound interest, and whether this is an arithmetic sequence or a geometric sequence. So let's write it both ways and kind of explore what this would look like. If it's simple interest, that means that Sam is getting 10% each year, which is $500, and so it'll just be the same each year. So we can just assume year after year, $500. We could write a sequence maybe that looked like this. $500 is the common difference. And what else do we need to know for an arithmetic sequence? Well, our formula is going to be year 1 or year 0, depending on which form we're going to use. Let's use year 1. So the equation is f of n equals the common difference, which is 500. If we're using n minus 1, then we can use year 1. Or we could use the year 0 formula, which uses f of n equals 500 n, and then we use year 0. The interesting thing about this is that if you plug in 20 into either of these, we get 20 times 500, that's 10,000, plus 5,000 is $15,000, is what you'd get either way with either of those formulas. So now if it was compound interest, then at the end of the first year, he'd get $500, but at the end of the second year, he's going to get 17%, but it's not 17% of that original amount. Sorry, it's 10% that he's getting. Let's make a little chart here. So year 0, he'd still have 5,000. Year 1, if it's compounded yearly, he'd have 5,500. But at year 2, he's going to have to do 10% of 5,500. That's what he's going to get paid. So let's write an equation and start plugging things in. It might be easier. So if our original amount is 5,000 and 10% is our ratio, we can say after that first year he has 110%. So we can say 1.10 is our ratio every year that he'll have 10% more than what he had at the beginning. And we'll say n minus 1. Well, for year 2, it'll be 5,000 times 1.1. And let's go down and let's compare year 20. So for year 20, we'd say $5,000 times 1.1. We can leave off the 0 to the power of 20 minus 1. Let's figure that out. That looks like it's 30,000. So if it's $30,579.54 versus over here he had half that much with simple interest. This is why they say if you invest your money, you want to get compound interest. If you borrow money, you want simple interest. So I'm going to make a note here. Simple interest is what you want when you borrow. Compound interest is what you want when you invest, because you want people to pay you money on the money you're earning every single time.